All right, here we go into our last chapter of the course, chapter 12. And chapter 12 is actually maybe three different parts. The first one is just talking about the algebra of functions. How do you take functions and add them and subtract them and multiply them and divide them? The second part deals with exponentials and exponential functions. And then the third part deals with the inverses of exponentials, which are log functions or logarithmic functions. So here we go. The first section we're going to do here is simply on how do we combine functions using algebra. And the first four ways we're going to combine them are very simple. We're going to find their sum, which means I simply add them together. We're going to find their difference, which means I simply subtract them. Their product means I'm going to multiply them, so I'm going to have to be using a lot of algebra here. Quotient, of course, means I'm going to find, use a division problem, so I'm going to make a fraction out of them. So for our example, I give you two functions. Here's my f of x. They both happen to be linear functions. And here's my g of x. And we're just going to do those four basic operations with them. So if I want to find f plus g of x, that simply means I take f of x plus g of x, which is just going to look like x plus 3 plus 3x minus 1. Well, that's going to be 4x plus 2 when I combine like terms, and that is f plus g of x, and you're done. Can't be much simpler than that. Well, how do I subtract? Well, I'm going to take my f of x and I'm going to subtract my g of x, which is going to be x plus 3 minus, now we have to be careful here because I'm subtracting that whole function. Make sure you put it in parentheses, because I'm now going to distribute through the negative. And I'm going to go ahead and I'm going to combine my like terms. So f minus g of x will be negative 2x plus 4. And there you go. Let's go ahead and let's find their product or multiply them. So again, that means I'm just going to take my f function and multiply it by my g function. So my f function is x plus 3, and I'm going to multiply that by my g, 3x minus 1. Well, look at that. How do you think you multiply those? You're going to FOIL. So my f times g of x function would be 3x squared. Outside I get negative x, inside I get plus 9x, and L is going to be negative 3. So that's going to be 3x squared plus 8x minus 3. And finally, f divided by g of x. I'm going to have to rewrite that. I kind of went down there too much. Means I'm simply, again, going to take my f of x and put it over my g of x. So in this case, it's going to look like x plus 3 over 3x minus 1. Now, one thing that you have to be careful here is you have to take into account the fact that there's going to be a value or values that could possibly make that denominator a 0, and you want to exclude them. So you want x not to equal, well, what's the one value that would make this equal to 0? Well, if you can't tell by just looking at it, you can go over here, use some scrap, and set it equal to 0. So I'd add 1 and divide by 3. That one value is 1/3. If x was 1/3, I'd have a denominator of 0. So x cannot equal 1/3. All right, so there is your four basic operations. Those shouldn't be too bad. We have another operation that we do with functions, and it is called the composition of two functions. there are two different notations that you're going to see. This notation right here is exactly the same as this notation. They mean exactly the same thing. They are both read f of g of x. So I'm going to flip my paper over to the back, and I just want you to watch as I kind of talk about this. So if I have a function, I'm just going to throw two functions up here. How about 3x plus 2 and g of x? Don't write this down as x minus 1. I just want you to watch. So we know about function notation. We've talked about it before. We know that if I want f of 0, that simply means that I go to my f function and I plug a 0 in for x. We know that if I want f of 3, that simply means that I go to my f function and I plug a 3 in for x. We know that if I want g of 2, I simply go to my g function and I plug in 2. We know that if I want g of a, I simply go to my g function, and wherever I see an x, I put an a. So whatever's inside the parentheses gets plugged in for the x. So if I want f of g of x, I take my g of x function and I plug it into my f function for x. If I want g of f of x, I take my f of x function and I plug it into my g. So what composition is it's really just plugging one function into another function. So that's what composition functions are. So I'm actually going to do these examples out of order. I'm going to go and I'm going to do C and D first, because those are the ones I really just talked about. So again, this means exactly the same as this. If you don't like this, write it this way. So now, what does this mean? It means I'm going to take my g function and I'm going to plug it into my f function. So if I go back up here, that means I'm going to take my g function and plug it into my f function for x. So if I want f of g of x, I'm just going to take and I'm going to plug in a 2x plus 1 into x in my f function. I took my g and I plugged it into my f. And then, of course, you'd have to FOIL this out. So it would be 4x squared plus 4x plus 1 if you FOIL it out. That is f of g of x. And again, I took my g and I plugged it into my f. Let's look at D. What does this say I'm going to do? This says I'm going to take my f and I'm going to plug it into my g. So for g of f of x, here it is written the other way, I'm going to take my f function, so that's my x squared, and I'm going to plug it into here wherever I see the x. So that is simply going to be 2x squared plus 1. And you're done. There's no multiplying that out. So again, composition functions means you're going to plug one function into another function. Now, what if I want f of g of 2? Well, there are two different ways I could do that. I could first look at my f of g of x, which I just found. There it is. And I could plug 2 into my f of g of x. Do you see where that would be? F of g of 2. So if I plug 2 into here, 2 squared is 4, times 4 is 16, plus 4 times 2 is 8, plus 1. Do you see where I'm looking at 25? The problem with that is, if you do it that way, you first always have to find the f of g of x. Is there a way to do it without having to find the f of g of x? Yes, there is. All you have to do is you take your 2 and you work backwards. You plug that 2 into g first, and then you take that answer and plug it into f. So if I find g of 2 first, so I'm going to take a 2 and plug it into g. 2 times 2 is 4, plus 1 is 5. And now I take that 5 and plug it into my f. 5 squared is 25. Notice I get the same answer. You can do the same thing with this one down here. Let's not look at the g of f of x that I found below. Let's plug in my 2 for f, and then take that answer and plug it into g. So if I plug 2 in for f, I'm going to get 4. Take that answer, plug it in for my x and g. 2 times 4 is 8, plus 1 is 9. And there's composition functions.